All right, let's dive into a connection that you probably never saw coming: the psychoanalysis of Jacques Lacan and the seriously strange world of quantum physics. Now, I know it sounds wild, but stick with me, because this pairing might just reveal the secret blueprint for consciousness itself. Let's get into it.
So I want to start with a question that really frames our whole journey today. Artificial intelligence can do these incredible things, right? It can calculate, it can reason. But why can't it dream? Why can't it desire, or fall apart, or feel a real sense of loss?
Well, the idea here is that AI is, in a way, just too perfect. It can simulate intelligence, sure, but it's missing that messy, contradictory inner life that really defines us as humans. It doesn't have the fractures, the fantasies, the desires that make our consciousness what it is.
So how do you even begin to map something like that messy interior world? Well, today, we're going to use two very, very unlikely languages. Think of them as two completely different maps that, somehow, seem to be describing the exact same landscape.
So on one side, you've got Lacan's psychoanalysis. This is a theory that describes the human mind as this fractured thing, kind of held together by these knots of language and desire. And on the other side, you've got quantum mechanics, a theory of reality built on unstable, deeply weird, and relational systems. I mean, these two fields seem like they're worlds apart, right? But as we're about to see, their underlying logic is, well, it's shockingly similar.
And this, right here, is where things get really fascinating. We are not just talking about a simple metaphor or some kind of loose comparison. The core idea we're exploring is about a deep, structural, shared logic.
So let's be super clear about this. The claim is not that the human mind is a quantum computer. That's not what we're saying. The claim is that the structure of the human psyche, as described by Lacan, and the structure of quantum systems share these profound architectural patterns. They're built in surprisingly similar ways. It's about the blueprint, not the building materials.
So, let's actually explore that architecture, shall we? We're going to look at a couple of specific parallels that really show off this shared logic between our inner world and the quantum world.
Okay, this slide shows you the whole scope of the idea. The source material actually points out 7 of these distinct structural parallels. Now, we're not going to go through every single one, don't worry. But the main takeaway here is that this isn't just a coincidence or two. It's a deep, recurring pattern. We're going to zoom in on 2 of the most striking examples, the Borromean knot and this idea called extimacy.
First up, Lacan's famous Borromean knot. He used this thing to model the human psyche. You've got these 3 rings, and they represent the 3 registers of our experience: the real, the symbolic, and the imaginary. But look, they aren't interlinked like a normal chain. No, they're held together in this incredibly fragile way where if you cut just one of those rings, the whole structure just, poof, falls apart. For Lacan, this is us. This is our subjectivity, a delicate, totally interdependent system.
Now, check out the quantum parallel, something called GHZ tripartite entanglement. In this case, you have 3 totally separate quantum particles, but they're linked up into a single coherent system. They basically act as one. And just like that Borromean knot, if you measure or disturb even one of those particles, the entire entangled state instantly collapses. The whole system just unravels. Sound familiar?
So right here you can see that shared logic, crystal clear. Both the Lacanian psyche and the GHZ state are 3-part systems defined by this radical fragility. Their very existence as a coherent whole depends completely on every single part staying exactly as it is. It's this logic of a 3-part, non-local binding. It's pretty incredible.
Okay, let's look at our second parallel. This one is one of Lacan's most fascinating and honestly kind of mind-bending ideas. He called it extimacy. It's a mashup of exterior and intimacy. And the idea is that the most intimate, central part of you, the thing that gives you your very identity, is actually located outside of you. It's an intimate exterior that literally holds you together.
Now, let's jump to the quantum world. We find something shockingly similar in what are called PT symmetric systems. See, on their own, these systems are fundamentally unstable. They just fall apart. But something really remarkable happens when they're paired with an external partner state. This partner, which is totally outside the system, allows the otherwise unstable system to achieve stability.
And there it is again. A shared logic just pops right out. In both the psychoanalytic model of the self and in this quantum physical system, stability isn't something that comes from within. The inside is fundamentally held up, made coherent by something essentially outside.
So look, these parallels are way more than just clever little observations. They give us a powerful new conceptual map. So what's the big deal? Why does any of this matter? What are we supposed to take away from finding these shared architectures?
Well, when you zoom out, you start to see that both Lacanian theory and quantum physics are describing systems that build their consistency around leftovers, things that don't quite fit. They find stability through these fragile, non-local connections. They form their identity based on what is excluded, and they build coherence through outside intervention. This isn't just about the psyche or about particles. This suggests a really profound set of principles for how any complex system gets a stable yet fragile identity.
And that, believe it or not, brings us full circle, right back to that question we started with about artificial intelligence.
Just think about this image for a second. Human identity isn't some solid block of code. It's a delicate knot. It's a structure held together by tension and by fragility, a structure that can, and sometimes absolutely does, unravel. And that is the very thing our current AI systems just don't have.
So, maybe what we call human nature, with all of its messiness and its contradictions and its desires, maybe it isn't a rational chaos after all. Maybe it's just a deeper, stranger kind of order, a structural logic that quantum physics also happens to describe, an order where desire itself has a kind of geometry.
And that leaves us with one last big, provocative question. If we ever want to create an AI that truly gets close to human consciousness, will we need to build in these very fractures? To think like a human, must an AI first learn to desire, to lack, and to be held together by a knot that could, at any given moment, just come undone? It's a lot to think about.